Class 10, Chapter 10, Circles, Module 1 and 2. Objectives. In this module, you will learn about tangents to a circle. The tangent at any point of a circle is perpendicular to the radius through the point of contact. The lengths of the tangents drawn from an external point to a circle are equal. Now listen carefully, some notes. Consider a circle and a line PQ. There are three different cases. First case, listen carefully the figure. Here the line PQ and the circle have no common point. In that case, the line PQ is called non-intersecting line. Now the second case, the line PQ and the circle have two common points, A and B. In that case, that line is called secant of the circle. Then the last case, here the line PQ and the circle have only one common point, A. In that case, the line PQ is called a tangent to the circle. Now that tangent to the circle is important for you. Okay. Now the example of tangent to the circle. That is a pulley fitted over a well which is used in taking out water from the well. Here the rope on both sides of the pulley, if considered as a ray, is like a tangent to the circle representing the pulley. Now the tangent to the circle is some other points. So listen carefully in this figure. So many secants are there, and listen carefully through the point P. Through that point P, we can draw only one tangent to the circle. All the others are, listen carefully, all the others are secant. So listen carefully. What do you mean by tangent to the circle? If a line touches the circle at a fixed point, then that line is called what? Tangent to the circle. So listen, there is only one tangent at a point of the circle. The tangent to the circle is a special case of secant of the circle. When the two endpoints of the secant coincide each other, then that secant become a tangent. Okay. Now the next point, listen carefully this figure. There are two parallel tangents to a given secant. So consider that secant PQ. For this secant, how many parallel tangents we can draw? Only two parallel tangents we can draw for the given secant PQ. Okay. Now the last point. The common point of the tangent and the circle is called the point of contact. Okay. And the tangent is said to touch the circle through that point of contact. That is, that point of contact we can name it anyone. P, Q, or any number. Okay. Any letter we can name it. So the tangent and the circle is joined together through that point of contact. Now the first question, listen carefully. The theorem. The tangent at any point of a circle is perpendicular to the radius through the point of contact. Listen carefully, students. The two theorems in this chapter. The two theorems are very important. Okay. So listen, the tangent at any point of a circle is perpendicular to the radius through the point of contact. Now listen carefully this figure. For the proof, given a circle with the center O and a tangent XY to the circle at a point P, the point of contact P, we need to prove that OP is perpendicular to XY. Take a point Q on XY other than P and join OQ. The point Q must lie outside the circle. Listen carefully. If Q lies inside the circle, XY will become a secant and not a tangent to the circle. Therefore, OQ is longer than the radius OP of the circle. That is OQ greater than OP. Since this happens for every point on the line XY except the point P. So OP is the shortest of all the distances. So OP is perpendicular to XY. Clear? So listen carefully. This theorem you can write your own sentence, but all these points are important. That is that secant point and OP is the shortest among them, which is perpendicular. All that points are very, very important. Okay. Now listen the first question. A tangent PQ at a point P of a circle of radius 5 cm meets a line through the center O at a point Q, so that OQ is equal to 12 cm. Find the length PQ. We need to find out the length, which one? PQ. So radius is given 5 cm, OQ is what? 12 cm. So we can apply what? Pythagoras theorem. How can we apply the Pythagoras theorem? Listen, if it is right angle triangle, we can apply Pythagoras property. So in this case, OP is perpendicular to PQ. That is our theorem. So angle P is equal to 90 degree. Now in triangle OPQ, OQ square is equal to OP square plus PQ square. Now OQ what? 12. 12 square is equal to OP square what? OP 5 square plus PQ square. So PQ square is equal to 12 square minus 5 square, which is equal to 144 minus 25 is equal to what? 119. Now PQ is equal to what? Square root of 119. Okay. Now next one. Draw a circle and two lines parallel to a given line, such that one is a tangent the other and the other is a secant of the circle. So listen carefully in this figure. So three lines are there. So draw a circle and two lines parallel to a given line. So two lines parallel to a given line such that the condition what? One is a tangent. So here which one is the tangent? RS is the tangent. And the other is secant of the circle. So PQ is the secant. The given line is which one? The last one, L is given. Okay. So one is a tangent, other one is the secant of the circle. Now the next points. Number of tangents from a point on a circle. So listen carefully here. If a point P lies inside the circle, through that point P we can't draw any tangent to the circle. Clear? Now the second case, if a point P lies on the circle, then through that point we can draw only one tangent to the circle. After that, next one is what? Outside the point P. If a point P lies outside the circle, from that point P we can draw two tangents to the circles. So these are the points, case 1, case 2 and case 3. Okay, now the theorem 2. So it is simple one theorem and also important one. That is, the length of the tangents drawn from an external point to a circle are equal. So the length of the tangent means from the P, outside point P, two tangents we can draw. One is PQ and PR. So the length of the tangent drawn from an external point to a circle are equal. That is what the theorem statement. Now listen. Given a circle with a center O, a point P lying outside the circle, and two tangents PQ and PR on the circle from the point P. We need to prove that PQ is equal to PR. For this, we join OP, OQ and OR. Then angle OQP. OQP and ORP are right angles. Why it is right angles? using the theorem 1. Okay, because these are the angles between the radii and the tangents. And according to the theorem 1, they are right angles. Now in right triangles, OQP and ORP. First condition, OQ is equal to OR. Second condition, OP is equal to OP. So that what is that? OP is equal to OP is a common point. Now in triangle OQP, congruence to triangle ORP using RHS. One is right angle. Which one? Angle OQP and ORP are right angles. Then hypotenuse. Which one is hypotenuse? OP is equal to OP, common for that. Then what? Any one side. So OQ is equal to R. Any one side is equal. So using RHS congruence rule, these two triangles are congruent. If that two triangles are congruent, we need to prove what? PQ is equal to PR. Why it is PQ is equal to PR? Yes. What is CPCT? Corresponding parts of the congruence triangles. If the two triangles are congruence, we can write what? PQ is equal to PR using what? CPCT, that is corresponding parts of congruent triangles. Now the next third question. From a point Q, the length of the tangent to a circle is 24 cm and the distance of Q from the center is 25 cm. Find the radius of the circle. Same type question. We can apply Pythagoras property. That is, here OQ is equal to 25, PQ is equal to 24. How we find out OP? So OP square is equal to OQ square minus PQ square. That is what? 25 square minus 24 square is equal to what? 7 centimeter. That is 49 OP square. Then OP is equal to what? 7 centimeter. Now the next question. If TP and TQ are the tangents to a circle with a center O, so that angle POQ is equal to 110 degree and angle PTQ, we need to find out angle PTQ. So angle P and angle Q are 90 degree. Why it is a 90 degree? Using the theorem 1, that is OP perpendicular to the tangent TP. Same as OQ is also perpendicular to the tangent TQ. So what? Angle P and angle Q are 90 degree. So angle P plus angle Q plus angle O plus angle T is equal to how much total? Yes, 360. So last we need to find out what? Angle TOPTQ, which is equal to what? 360 minus sum of all that 290, which is equal to 70 degree. Now the last question. If tangents PA and PB from a point P to a circle with a center O are inclined to each other at an angle of 80 degree, find angle POA. Board exam question, important one also. Okay. So solution. Angle APO 40 degree. Why it is 40 degree? So listen carefully. This one is what? AP is equal to BP. So listen carefully. This one total angle APB is equal to what? 80 degree. Now it is congruence triangle using the theorem 2. So it is angle APO and angle BPO are equal. So angle APO we consider what? 40 degree. Now angle APO plus angle POA plus angle OAP equal to total what? 180 degree. So angle APO 40 degree plus angle OAP how much? 90 degree plus angle POA is equal to 180 degree. At last angle POA is equal to how much? 180 minus what? Sum of 90 plus 40, which is equal to 50 degree. Clear, students? Okay, thank you.